Hello and welcome back to AIT 1001. My name is Matt Luckett and we are ready now for Lesson 2. Lesson 1 we covered just some basic parts of electrical circuits. We found out what made up an electrical circuit. We learned a little bit about schematics and some of the symbols used in a schematic. And now we're ready to move on to Lesson 2 and go over the list here of what we're going to cover in Lesson 2. First thing we're going to cover is identify various conductors and insulators. There's a wide variety of different types of conductors, materials, insulation materials, and depending on where these conductors will be used, it depends on what type of insulation and wire you choose. Things come into play like, is it extremely hot where the conductors are going to have to survive? Is it really cold? Are they going to be buried underground? Is it a wet environment? Is it a dry environment? Is it a corrosive environment? So these things all have to be considered when choosing a proper conductor for a given application. But you'll find out in the text some different types, some basic types of wires and insulators that are in use. We're going to demonstrate the process of stripping the insulation from a wire. This is something that sounds simple, but you need to be careful when you do it. If you do it improperly, you could actually damage the wire, which makes it harder for it to carry the current that it's supposed to carry, because you've actually peeled some of the wire material away. So we're going to delve into that a little bit more. We're going to explain how wire size is measured. The common unit used to measure wire is American wire gauge, or AWG. Those different wire sizes have a different gauge, so you may hear like an AWG 16 or 18. Those wire sizes, those numbers equate to a specific wire size. And that is covered in the text. We're going to, and also explained in the text, explain why fuses are used to protect electrical circuits. Fuses are an important safety device. They essentially protect you from fire a lot of times. In your home you have circuit breakers, but a lot of equipment, fuses are used because they can react a lot faster than a circuit breaker. But circuit overcurrent protection is important for a number of reasons. One, like I said, for preventing fires. It also can be used to protect the equipment. If something happens, if there's a surge in power or something, that fuse could blow and open the circuit and protect the equipment that's after the fuse. If you have a high current situation, if there were no fuse, a wire or conductor would actually get hot enough to melt the insulation, and which could also create a fire. So, like I said, you're going to learn more about fuses in the text, and then the last thing we're going to cover is demonstrate the process of soldering the wire and the use of a heat sink. So this is one thing you're going to be doing when you come to the lab. You're going to be creating splices in wire using various methods. You're going to be gauging the wire size and being able to identify a given wire size using a tool to be able to gauge the wire. So in Lesson 1, I did a short presentation on an area that I felt like needed more attention. For Lesson 2, we're not going to do another presentation. We're actually going to do a demonstration of how to use a soldering iron. We're going to do some tinning of wires. We're going to strip the insulation from a conductor using wire strippers. We're going to construct a wire splice using a wire nut, butt splice, and using solder and heat sink. So that's what you're going to be doing when you come to the lab. That's what I'm going to be showing you in my demonstration. As before, if you have questions, please post them to the Q&A discussion board. Email me, call me, or stop by my office. I'm available. And so for the next part, after this video, you'll want to play the demonstration video, which will have the items I just discussed. Thank you.